Okay, guys, we're gonna talk about chemical reactions and energy today. Okay, we're gonna start that unit. And so here we go. We're gonna talk about what is a change and what are the signals of a change, physical change versus chemical reactions, conservation of mass, types of energy, changes in energy during a reaction, temperature versus thermal energy, and energy flow, okay? The first thing we're going to talk about is changes in signals. Alrighty? And you remember last year, we studied the properties of matter in the context of, and we said that we defined chemistry as the properties of matter and how matter changes, right? We studied that last year. And so what does it mean to say that matter changes? And how do you know that matter changes? Okay, so for example, if someone were to put a piece of ice on your table in front of you there, what's going to happen to that ice? What's going to happen to it?
Melt.
It's going to melt, right? It's going to melt. So it's going to change from a solid to a liquid, right? Okay, so how about if we took some liquid, put it in a flask or a pan or something, and we turn the heat up on it?
It's gonna melt immediately.
It's going to turn from liquid to what?
Hot water.
Gas, right? Well, it's going to get hot, right? It's going to get hot, bubble. It's going to get hot and bubble, and it's going to it's going to evaporate, right? Turn into a gas. Okay, so, and how do we know that how do we know it's turned into a gas? What do we do?
It steams, smokes.
Well, okay, so a change is when properties of a substance are different before and after something happens, right? But how do you know when the properties are different? Well, what do you say? Observe, good, I like that, observe. Okay, we observe, or what's it, we see it, right? We see or observe. Observe, see, some people say watch, all the same thing, right? That's the way you know when properties are different, right? You observe it. Okay. Okay, so the key is observation. Unless you can observe something, you don't have proof that it happened. Okay? The easiest way to make observations is with your five senses, right? Okay, good. And so, so what are these five senses here? What's the first sense? For example, you're watching that ice melt. What are you doing?
Sight.
Sight or see, right? Sight.
Then smell, hear.
Smell. Okay, what's another one you said?
Hear.
Hear. Good, I like that. Okay, what else?
Feel.
What?
Feel.
Touch.
Touch. Yeah.
I like that, touch. And what's the fifth sense? Taste. Taste. Now in science, that's something you have to be really careful about. Especially in a science classroom, never ever taste anything unless the teacher tells you to do so, okay? Because it literally can make you sick or kill you. Okay, so what do we say here? Taste. Those are our five senses, okay? Okay. Just type that in. For those of you at home, use your CAMI document and type these in. Sight, smell, hear, touch, and taste, okay? You might want to stop the video and then type those in that way. Okay, I'm going to move on here. Okay. Okay, so let's look at the first sense that we talked about. We talked about sight, right? So our eyes let us see properties such as what? Color, shape. In color, you know, red turns to green. You're at a stoplight. What happens? Traffic light goes from red to green. What does that tell you to do?
Stop out.
Tells you to do something. Tells you, well, if it goes from red to green, what do?
Go.
You go, right? Okay. Shape. You're rolling chewed gum into a ball. With the pandemic right now, don't be doing that. Don't be rolling your gum and then. Okay, got the idea? Size, like inflating a balloon. And then phase, you can also use the word change. Change and phase can be they're the same words, okay? Phase could be solid, liquid, or gas, okay? Or state, phase or state, like the states of matter. Phases of matter means the same thing. Okay, and then things like light and smoke. Things like light and smoke. Okay, so this is all sight, right? What you see, what you observe. Okay, and then there's hearing, okay? So our ears do hear one thing really well. They hear sounds, right? So something must have happened for a sound to be produced. For example, a pair of cymbals being crashed together. Got the idea? You can hear that, okay? Okay, then you got touch. Okay, so our sense of touch can let us know things such as texture change, like from solid to slimy. If you've ever made what is that? The slime balls. And then you have well, here's an example too. They use the example of hamburger grease melting. And then temperature change. It goes from warmer to colder. A glass of water with ice in it, okay? Those are examples of touch. You can tell that there's a change going on, okay? And then here's an important note about touch also as well. Now we said taste is very important not to do in a science class unless your teacher tells you to do so. But it also touch, okay? So unless your teacher tells you it's okay, never directly touch any substance in a lab, okay? Some substances are dangerous, and they can cause serious injury, so bringing your fingers near a container like a beaker is close enough to let you know if it's getting hotter or colder. So don't just grab something. You might want to approach it with your fingers close, and you can sense whether it's hot or cold. Okay, got the idea? Okay, now taste. Well, our taste buds can let us know, right, how something tastes, like strawberry ice cream. Okay, but again, what am I saying here? Never taste anything in the laboratory unless your teacher tells you to do so, especially if there's another way to get information safely. Okay? Okay, and then smell. Oh my. Ever smelled a banana after it's been in your house for several days? They get kind of funky and you get these little flies around them. Time to throw them out. So our nose lets us smell things as they happen in the laboratory. When a new smell is present, something must happen to cause that smell. And they use the example of the rotten tomato, or rotten banana, right? And one way to smell, don't put your nose up to something and smell it. One way is to bring it to you and waft or waft it. A good way to smell, waft or waft. We'll talk more about that later when we talk about lab safety. Okay. So you always waft instead of deep breathing them. Okay. Now let's look at some laboratory tools here. Sometimes we use tools in the laboratory to help us make observations, right? How long something is, what the temperature of it is. Okay. Okay, so here's some questions here. So you should be on and you at home, you should be following me on the slide that you have. And I'm going to ask you to answer some questions. So, what is always different when a change occurs? Well, here's your choices. I'm going to let you choose A or B. Can't choose C. Can't choose C. It's either A, a substance involved, or at least one property of a substance. So you mark your answer A or B. You cannot choose C. If you guys got an answer marked, you can draw. I'd suggest you draw and circle it. Circle the letter or circle the answer. Or draw a line underneath the answer. Either way will work. Okay, everybody got an answer?
Yep.
So A or B. Okay.
Can I say it in? Oh.
Okay, so let's look right here. So, what do you make during an experiment to show whether something is happening or not? Do you make observations or do you make predictions?
Prediction.
Mark your answer. You can choose observations or predictions. What do you make during an experiment to show, there's your hint, to show whether something's happening or not? We just talked about it.
Oh,
Don't bother an answer, just mark your answer. You can choose A, observations, or C, predictions. You do not choose explanations. Okay, so you can choose A or C. Got an answer marked? Okay. At home, if you need time to think, you can pause your video and answer on your presentation slides that you have. Okay? Uh-oh. Let's see, we're on number 3, is that correct? Jaleel? We're on number 3, is that correct? Okay, so, look right here. So which one of the following are not possible to observe with your eyes?
formula.
Okay, so, don't blurt out an answer. Can you see the color? Can you see a formula, or can you not see color? Can you not see a formula, or can you not see size? Mark what you can't observe. Something that's not possible to observe with your eyes. Color, formula, or size. Mark your answer. Got an answer? Good, okay, good job. Okay, so, let's move on here. Okay, so number 4. So, which one of your senses should you never use in the laboratory unless your teacher tells you to do so? Okay, now we talked about 2. So, I would accept 2 answers. I'll accept 1 answer, okay? Is it hearing, touch, or taste? Or is it 2 of those? Your choice. I'll accept 1 answer, I'll accept 2 answers, because as we talk about 2, okay, I'll accept 1 or 2 answers, you choose. We got an answer? Okay. Okay, again, if you're home and you need time to think, just pause the video, answer from your presentation slides. Okay, I'm gonna move on here. Okay, okay, so we talked about tools. You saw the slide with the tools. Okay, so which tool is best for helping determine the temperature of a substance? The temperature. Would it be a graduated cylinder or a thermometer? If you're measuring the temperature of something, would you use a graduated cylinder or would you use a thermometer? Mark your answer, B or C. Don't blurt an answer, just mark your answer. B or C. Are you with me? Okay. Everybody got an answer? Okay. If we can get this done, we're gonna be finished. Okay, so which tool is best for helping determine the volume of an irregularly shaped object? Okay, if I have a rock and I want to measure that rock, what would I use? Would it be better if I used a ruler or a graduated cylinder? Mark your answers. We actually talked about this last year when we talked about matter. You should know this one. Okay. Ruler or graduated cylinder, A or B, mark an answer. And I think that might be the last one here. And we're going to talk about physical change versus chemical reaction tomorrow. Okay? See you then.